Hello बच्चों, let's look into this question. In this question we are told what is the digit at the hundredth place of a number 375 raised to the power 60. 375 raised to the power 60. Now typically whenever we are supposed to calculate hundredth place of a number, it is as good as saying find the digit at the, so on any number ABCD divided by 1000 will give you the last three digits of that number. So typically we have seen last two digits, unit digit. This one is a last three digits. Now let's see how we can proceed with this thing. We'll just have to factorize 375 to get the primes. So 375, as we know, can be written as 3 into 5 cube. So this is the prime factorized form of 375. Similarly, for when we divide it by 1000, for 1000 we can write it 2 cube into 5 cube. So let's write those numbers down. So this can be written as 3 into 5 cube whole raised to the power 60 by 2 cube into 5 cube. Okay, now let me create some space. Now this can be broken down into the numerator of this part, or the dividend of this part can be written as 3 raised to the 60 into 5 raised to the 180 by, you can either write it 2 cube or 8. So I'll write it as 8 only. 5 cube can be written as 5 cube only. Now at this point what I will do is I'll try to eliminate 5 cube in the denominator. So I'll just remove 5 cube from the picture. Now please remember, whenever we eliminate something from the remainder, we always have to multiply that number back into the remainder at the end of the answer. I hope that is clear. Let's proceed further. So now this entire expression can be written down as 3 raised to the power 60 into 5 raised to the power 177 by 8. Now what we can actually see from this part is that, now please remember that 3 has a cyclicity of 4, or in other words you can say the power cycle of 3 is 4. Either we can go that way, or you can easily do this thing by doing 3 square raised to the power 20 by 8, whatever the remainder is, multiplied by 5 raised to the power 177 by 8. This will be the same thing. Now if you recall, the Euler number for 8 is 4, and by Fermat's little theorem what we know, that anything raised to the x by n raised to the power Euler number of the divisor will leave a remainder of 1. So directly this thing, the remainder will be 1 from Fermat's little theorem. We have to check whether 3 and 8 are co-prime. In this case, obviously 3 being a prime number, 8 and 3 both are co-prime. Let's try and do that thing for this part. So let me create some space over there. So 5 raised to the power 177 can be written as, so I can write it like 5 raised to the power 2, that gives me 25, and then I can raise it to the power 22, that will give me 176, and 5, because 177 is an odd number, I cannot do it like this, divided by 8. Now this will typically give me, and please understand that 5 and 8 are also co-prime, again with the application of Fermat's little theorem, because 5 is raised to the power of 4k, 4 being the Euler number of 8. The remainder for this part also will be 1, but there is an additional 5 that is multiplied into this expression. So the remainder for that entire expression will come out to be 5. Now, is this the final remainder? Obviously not. I have told you in the very beginning that 125 that we have eliminated from the first part of this equation will have to be multiplied back. So 5 into 125, ultimately the remainder will be, so the final remainder to this question will be 625. Okay, but this is not the answer. The answer was to calculate the value at the 100th place, or the last 3 digit we have to calculate. Typically, because the question has asked us specifically about the 100th place of the number, we'll only be looking at 6. So in this question, the answer to this question will be 6. Let's see in which of the options we are given that. So option number D is our correct answer. Option number D gives 6. So I hope you understand this thing. Thank you.